Hello viewer, welcome to this video. It's a continuation of some exercise that we did as far as linear programming is concerned, and I want to do question 1, 2 and 3. Then in question 4 to 13 I'll also create a video for that. Okay, so the first question in this exercise 7.2 reads, a firm is to hire 2 employees. One of them is to earn twice as much as the other, and their total salary should not be more than 39,000. Find the maximum salary that can be paid to the less paid employee. Okay, so the first thing that we need to do is to imagine that we have the salary for the person who is earning the smaller amount, and then from there we can be able to come up with an inequality that will allow us to get the minimum amount that the less paid employee gets. So let's get to the solution tab here. So we are told that a firm is to hire 2 employees here, and one of them earns twice as much as the other. So if we say there are 2 employees, A and B, these are 2 employees. The first one earns, let's say, earns X, so the other one earns 2X. So you find that B earns twice as much as A, right? And then you are told that their total salary should not be more than. So okay, I remember last time I told you that the word or the phrase not more than simply means that less or equal to. Okay, so we have the sum, that is X plus 2X, should be less than or equal to 39,000. In other words, when you add their salaries, it should not exceed 39,000. So here we can solve this linear inequality. We have 3x is less than 39,000, and so x is less than or equal to 13,000. That is when you divide 39,000 by 3, you get 13,000. So it simply means that the employee who earns the minimum amount should not earn more than 13,000, and so 13,000 is the minimum amount. So 13,000 is the minimum, or the maximum, I should say maximum, not minimum, maximum amount that the less paid employee gets. Okay, yeah, so maximum of 13,000. Okay, that's question number 1 we have done. So we go to question number 2. Question number 2 says the sum of 2 integers is more than 10. The second integer is twice the first integer, and the first integer is less than 6. So taking the first integer as x, form all inequalities in x representing the given situation, and find the range of values for x. Okay, so you know what an integer is. Of course, a whole number which can either be negative or positive, and in this case we are going to take the first integer at the solution tab. So let's say the first integer, because it is smaller than the second one, so let's say this is the first integer, and then we have the second integer here. Okay, the first integer is x, so the second one should be 2x, because we are told that the second integer is twice the first integer. So it's wise to write x and then 2x. And then we are told that the sum of 2 integers is more than 10. So if you add these 2 integers, that is x plus 2x, it's bigger than 10. Solving this gives us 3x is larger than 10, and so x is greater than 10 over 3. Okay, so this integer we are calling x should be bigger than this fraction here, 10 over 3. And because we know that an integer is not a fraction, so whatever number we have there, let's say, because 10 over 3 is like 3 and a third, so we are talking of a number like 4 and so on. So let's get the next bit of the question that says the second integer is twice the first integer, and the first integer is less than 6. Okay, So the first integer, which is x, is less than 6. So if you combine these two simple linear inequalities, we can have this compound statement which says x is less than 6, and this x should be bigger than 10 over 3. So because x is an integer, what is our range now? Now given that this is 10 over 3 and this is 6, so those numbers are 4 and 5, because integers are either negative or positive whole numbers. And so we have 4 and 5. Between 10 over 3 and 6 we have 4 and 5 when these two are not included, because this is a strict inequality. So these are the integral values satisfying this condition. And if you want to check whether it is true, you're told that if we were to pick the first integer to be 4, you'll notice that if 4 added to twice that number, that is 4, you're going to get 4 plus 8, which is 12, and this is definitely greater than 10, which holds true for the condition we are given. If you take 5 again, 5 plus 2 times 5, this gives me 5 plus 10, which is 15, which is also greater than 10, and that holds true also for the condition we are given up here, that the sum of two integers is more than 10. Okay, so that's it. So we do the last bit here, which says Isa owns more than 50 animals, that is goats and sheep only. There are 20 more goats than sheep, which are not more than 30 in number. So by choosing a letter to represent the number of sheep, write down all the inequalities for the information and hence find the range of solutions satisfying the same. Okay, so we are told that Isa owns more than 50 animals here, and there are 20 more goats than sheep. So let's say in the solution tab here we have, we start with goats here and we have sheep. Okay, so if this is let's say the number of sheep, goats is x, sheep will be definitely equal to x minus 20, because we are told that the number of goats are more than the number of sheep by 20. Okay, again there is a continuation here that says that there are 20 more goats than sheep, which are not more than 30 in number. So when we say which are not more than 30 in number, are we referring to the goats or we are referring to the sheep? Here you need to be very careful, because this statement refers to the sheep. So it's the number of sheep that is not more than 30. So we are going to take now another inequality here that says, first of all, we take x plus x minus 20, and we know that those ones should be more than 50. That's what we are told. So this one should give us the first inequality. So 2x minus 20 is greater than 50. So adding 20 to both sides, it gives us 2x is greater than 70, and so x is greater than 35. Okay, that's the first inequality. All right. Okay, so the second part of the same is saying that the number of sheep should not be more than 30. So we are told that now, because we know the number of sheep is x minus 20, this should not be more than 30. So it should be less or equal to 30. Remember, the term or the phrase should not be more than. That simply means less or equal to, less than or equal to, I should say. So x is less than or equal to 30 plus 20. So x is less than or equal to 50. So we got another inequality here. So if you write now this statement so that you have now a compound statement, we will sandwich x between 35 and 50, and this is how I prefer to write it. So we have x less than 50, and now x should be bigger than 35. So you find that these animals, the number of animals should be in between 35 and 50, and that is the number of goats should be between 35 and 50, beyond which that cannot work. Okay, so we are also told to write down all the inequalities for the information, and hence find the range of solutions that satisfy. So we have the solutions here and the range between the x, the number of goats should be between 35 and 50, and that's how it is done. Thank you.